Great. So in terms of your project, can you give that first intro or the high level maybe pitch if you describe for people what you had to do for your master's applied computer science project in your internship?
Okay. Um, to be honest, I see like in my workplace, most people don't understand when I talk about buoys because they don't know what buoys are. I didn't know what a buoy was until I took on this project, to be honest. So basically, what my project was about, predicting values from a particular buoy, using those values to try to predict the same values in another buoy. So at the Port of Halifax, there's a Smart Atlantic buoy project that they've been running. So they put in buoys in the harbor to measure ocean conditions, wave, wind, wave heights, currents, wave direction, things of the sort, for so that ships can come into the harbor and dock and, just to aid commerce and whatnot in the harbor. But the thing is, ever so often, they have to go for maintenance, the buoys, and so they take one of them out of the water and into maintenance. And for that period, there's no way for data to be collected about ocean conditions and things like that. So DeepSense, in collaboration with Cove and some other wonderful groups, came up with a premise of, trying to see if we can predict the values of that buoy that goes in maintenance using a different buoy that's farther out in the ocean. So that's what the premise of the project was. And we'll go through the processes of how everything was done in this talk.
That's great. And I think the way you just prefaced it makes a lot of sense because I think it's one of those things where no matter what project you're doing, you're going to go through similar steps. And I think that your experience was a really good lesson for us too, because it was using something different than we'd ever done in terms of the data and how it was structured. So can you talk a little about, what we talked, you just said there's a buoy that was in the harbor and you were going to try to predict those values. What data do you find to try to make those predictions with? Can you talk about the struggles we went through trying to find
definitely.
Prediction capable data?
Yeah, definitely. So the thing is, I was mostly seconded to Cove for the internship, and Cove is in the Port of Halifax, so they didn't have so much information about the Smart Atlantic buoy project itself. So in order to get data, we had to go through different sources. You could find data on some websites like the ECC website, which is Canada's oceanography website. You could find some data there. Or we had to talk to some professors that were doing research with some of the buoys and ask them for what data they had presently. Or we had to go through the ropes totally. We had to speak to the Department of Fisheries to get more data from their AZNP buoy. It was, in the beginning, we were all over the place, to be honest, because it's not a software organization. And it's also not a statistical organization. So to pinpoint the data you needed, we had to go to different places, through different people just to find the data. And another problem was like the data, they were different. You had to siphon through the data and pick out what you think correlates amongst the different sets that you gotten. So in the beginning, we're definitely all over the place. But thank God we got our heads together in the end.
I think so. One of the things that's most fascinating about working in DeepSense and working with companies to try to build out models that make predictions and try to help explore what kind of machine learning solutions they can have. One of the biggest gaps that organizations have is not having data. And so then you had that challenge of somebody knew what problem they wanted to solve, but they also didn't have the data, and then you had to go find the data. So we'll talk in a minute about the challenge you had to figure out in what prediction values, which was its own inherent challenge. But can you tell us a little about, as you found the data and you found these external sources of data, what challenges did you run into when you were trying to understand, interpret, and clean that data? Okay.
Firstly, I was new to the ocean space because most of the projects I'd done in machine learning were mostly school projects, and they dealt with text analytics, handwriting recognition, things of that nature. So, when I first saw the ocean data set and I saw sort of like data dictionary for it, all I was seeing were mathematical values and old notations and things like that. And I didn't understand anything. But Cove provided a data resource for me in a person, which was Toby. So he could help explain some of those values, what they meant, what mattered the most. And Cove was gracious by helping me contact some of the stakeholders that were to use this project. And they told us, what values mattered and how to go about understanding it or what the purpose was. Sometimes they couldn't give a definite definition about some of the data, but they could tell you about the purpose. And from the purpose, you can interdict on what you need the data for, what you might need to do with the data. So for the data resource that it provided was the best thing for me at that point, because it was a marine researcher to help me understand, what some of the values were, what mattered, what didn't matter, what I could cut out, and what values did need to predict the most, which ones matter the most in parts of artifacts.
I think it was fascinating. Like some of the stuff that you ran into were things like negative win values, which were physically impossible, right? And then even some of the things I remember us talking about were things like, what do you do when you're handling missing values? Do you clean out that data, or are you now all of a sudden cleaning out data that should have an average or some other alternative because you're making your model a little biased because you suddenly don't have certain data pieces? And I think is there any other things that you remember running into with some of the data? There are specific examples you can give so people can understand, oh yeah, okay, now I can see why wind values are issues.
Yeah, firstly, the wind values were, some of them were skewed because you were having minus 1,000 kilometers, which is impossible. And then there were also location values. I mean, we're in Halifax, and then when you convert the location values to coordinates, you find Uzbekistan, and you're like, the buoy is not in Uzbekistan. It should be somewhere in Halifax. So you have to figure out what the right coordinates were, change them for one. Somewhere as easy as just, they could be minus values, negative values. You just multiply them by a negative sign and it will become positive. So some things were easier, while others were, you had to engineer the data, create averages, moving averages, going backwards for some of the data. So it made me learn new things that, you could do possibly before with pandas and NumPy, but it definitely expanded my scope and, my reach for cleaning the data set. Most of the project was about data engineering. I still feel like there's so much information in the data that can be used to build on better models, such as, classifying things like wave directions, wave swirls, putting values for them if you're within a certain range, maybe not east, things of that nature. We didn't have enough time to go into that, but there's still a lot of data to be engineered from the data set that we have.
I think, well, and so because of that, that's a great segue into one of my next questions. I think one of the things that we ran into is, working with people who maybe don't have a lot of experience doing any type of data analytics and predictions. So I do recall having discussions with people where we said, okay, here are all of these measures that are coming off of this buoy, which ones are important for us to try to predict? And I remember someone at one point saying, well, all of them.
Yeah.
And then our point was, well, your model's really only going to predict one. So let's figure out which one of those variables, measures, targets that you want to have. Can you talk a little about the business element of it, or like the strategic discussion? Like, do you remember, is there anything you can share of advice or experience around trying to help others see why you needed to narrow down what was the most important measure for us to try to explore?
Okay. Yeah. Initially, when I started, when I had the meetings with the stakeholders, Cole, the part of Halifax, Captain Ray, everybody was like, everything is important. And to be honest, I got a little lost in the weeds, trying to do everything, trying to please all the stakeholders, trying to do everything. And at the point I discovered it was untenable. I mean, the stakeholders, they definitely saw value in the work that was to be done. But the problem was, we're all new to this. So the problem was doing that work and then carrying it forward, like incorporating it into an operation that the business will have to handle eventually. So in the beginning, it was, I've heard a lot about machine learning from stakeholders. They say you can do this, you can do that, it works like the brain, works like this. But in all honesty, it's not really that, because it was a bit stressful, because I remember going into all sorts of correlation mappings, data analytics, visualizations. And then I had that meeting with Chris where we retooled everything, spoke to the stakeholders and said, okay, let's start with a modular approach. Try to predict this first, then see what, how the values relate to each other, like your X and Y variables, the independent variables and dependent one. Because when you say, everything is important, how do you determine what should predict what? Because the idea I got from when you said everything was important was that almost everything kind of seemed independent. But first, you have to determine what relations existed between them. Correlations, but not causation, though. The correlations, what existed between them. What will be a better predictor for what? Things of that nature. But eventually, I couldn't establish the bounds of, a way to push back on them. But Chris helped me with that. He spoke to them that, okay, we'd start with this. I mean, I knew what I needed to do to get things done, but I also, being a student and being, new in that scenario, I also felt like I had to do everything they mentioned. So Chris helping me, push back with that or set boundaries was really helpful for me.
That's great. And so then for some other folks, Chris, he was our algorithms and software specialist. He's now a faculty member at Dalhousie. And we have a new algorithms and software specialist, Itika, who helps students explore the same things that you went through, where, trying to help the stakeholders understand what's really important. But I think it's one of those great examples that carries on, because if someone moves on to another role in whatever capacity is, whether you're a data scientist, a machine learning engineer, a developer, something else, you're always going to want to make everyone happy. But it was it was an interesting reminder too about how we communicate, how models can get developed, and what really you need to put into planning out that model. So, once you knew what your target measures were, how did you decide? And I know you worked with Chris and explored different options, but how did you decide what different types of algorithms to try and explore for best predictions?
Okay. So what we did firstly was we noticed most of the values that were to be predicted were continuous in nature. So we knew it was a regression type problem. And we noticed that some of the relationships between the values might not be linear. So we didn't want to try out for linear regression or things like that. So we went a level above to SVR, support vector regressors. And then we also wanted to, use ensemble methods. So ensemble methods is a methodology of training weaker models, a group of weaker models that then aggregate together or vote together to predict a certain value. So things like random forest, XGBoost, AdaBoost. So and then a neural network. So basically, we have three things we're going to try in mind. From our analysis and talking to some of the researchers, we knew that some of those relationships, and most of them, weren't linear. So we went for support vector regressors and then random forest algorithm, because also because of the ease. For me, I was just coming into that industry and product development stage for myself, and I was pretty conversant with random forest already, and it's an example of ensemble methods. So for my convenience, we also decided to use a random forest regressor, and then we used a neural network too for that, a deep neural network. But I'd used neural networks before then, but they were mostly for classification type problems, not regression type problems. So we got to experiment with different optimizers and activation functions for different layers and things like that. But Chris was there every step of the way, especially when I had to move off my laptop to, the cluster system, because on my laptop, I'm used to the GUI and all of that. On the cluster system, you're dealing with command line and the command line interface and things like that. So Chris was there to, provide me with lessons and tutorials for all of that. But overall, he also helped. Part of the factors was it was a regression type problem. Some of the best methods to use right now, neural networks and ensemble methods, they perform better than most. So Chris and I decided on that. And the easiest way to get those things done, because of the time constraint we also had, which is 4 months.
So there's so many different ways I can take this path too, because one of the things I think that's critical is by this point, you'd spent months acquiring, finding data, cleaning data, understanding those nuances. And then in terms of actually training your model, you started with your laptop. And as soon as you hit that neural net, probably it's slowed down a lot. So about how long, we're going to talk too about what it was like migrating to DeepSense's high performance computing infrastructure, but what was it like? Like how much time did you get a chance to spend training your models?
I'd say to be honest, maybe 3 weeks to a month, but I'll be honest. The first time when I started training the models, even for the support vectors, for the SVRs and the random forest regressors, I was already eating bottlenecks because I tried Grid Search CV there was a lot of space computations and matrices to go through. So my system had to be on for 2-3 days, which didn't make sense. Then I tried randomized search CV instead, because that just searches within random spaces instead of the entire space. I tried that too. Took a while. And I mean, I was getting some results already. I was like, fine, let's see what happens with this. But then when I went to the neural networks, it was forever. I left my laptop on for 2-3 days. It didn't work. So I just came back to Chris. And I was like, this is not working. So that's when we decided to migrate to the high performance computing cluster, because I tried to avoid it at first, to be honest, because I wasn't used to that. I was like, this might add some more complexity to my project already. So I tried to avoid it. But when I wasn't getting anywhere, I decided that was the best route to take.
I think that's a really good point, that we're, one of these things that we're really working through here is we work with students on some great projects. And because moving all of a sudden to a cluster, you're not dealing with your laptop anymore. You have less control. To your point about the GUI system, like if you're used to an interface that's a little bit easier and you're more familiar, it's so much easier to just keep it on your own stuff and just do it that way. But then, yeah, if your system's shutting down and you can't use your laptop for days and you're afraid to close it because, oh my goodness, your job's going to stop, then it's a bit of a nightmare. So one of the things that we're really working on here is trying to help understand the challenges of what a student goes through, or anyone, when they move to a cluster. So you already said you go to the command line. Can you talk a little about what it was like that first time you logged in and what you had to go through to actually use this system, and why you were happy or reluctant? I'm not sure what your feeling was when you first moved over.
Okay. When I first moved over to the cluster, Chris was beside me because he gave me a tutorial on how to go about running my model training on the cluster. So I just took notes down and everything I needed to do. But even after that, I didn't use it. I was still of the opinion that I could get by with my laptop till I get to neural networks and all of that. So I was like, I'll just go ahead with my laptop till then. But then, I'd used the command line before and AWS too, but just the term, the computing cluster, you get shivers when you hear that. You're like, okay, what's a computing cluster? Are you sure you should be using this before you mess something up? So I was like, okay, I'll just try it out once I get to neural networks. And the process was pretty streamlined for me because Lou Yang helped me with my login and credentials and all of that. I was using a Windows system, so I had to get, I've forgotten the name now, but there's this software, Putty, and all of that helps you log into the system through SSH and all of that. But I was also lucky because Jupyter was already pre-installed on the cluster, and Jupyter gives you a GUI, which you can use, a simple GUI you can use to navigate your file system and your directories and to build things on there. The place where I had to go through a new learning curve was when I had to schedule the jobs. I'd use cron jobs on Linux and all of that, but I didn't know about LSF or job schedulers or batch schedulers and things of that nature. So DeepSense has a wiki, which I used for the bsubs command, bjobs command, and how to set the amount of cores you need, the amount of RAM you need, things of that nature. So when it took about 2 days for me to go through the wiki to really understand everything. But to be honest, just because of the term high computing cluster, I thought it would take longer. So I was initially reluctant, but within the space of 2 days, I already knew what I had to do, how to log in and all of that. So it was pretty smooth from there.
So one of the things I think, it's talking about the pluses and the minuses. The minus was that you had to spend time learning, understanding your wiki, getting onboarded, and then figuring out how to submit jobs. I get that because it's not as simple as you just hitting go on your laptop. You have to add extra code and make sure it's right. The other thing we learn is if something's not done correctly, or if you articulated something that's in excess of your permissions, the job might just sit there forever. So you actually don't realize it's not actually going, it just kind of sits there. So there's always those negatives. But once you got onto the system, how much faster was it for you to retrain your models?
Oh, it was way faster. And I could also just leave my system or go on to do other things, because now all I was using was GUI, the Jupyter GUI that was sent over the network to me. So I could even close my system and leave the job running. So far, I don't log out of my system because when I shut it down, all connections end. But it was just, it was more convenient for me. I didn't have to bother about my laptop running for 3 days, screaming and getting really hot, things like that. So it was pretty straightforward for me once I was able to get onto the cluster. The only snag I had was when I was off campus, because I had to use DAO's VPN. And when you close your system, that goes off the department.
Yeah, that's a good point too, because when you're using a system, you have to VPN in, tunnel in, and then get some access. The other thing too that we've talked a lot about as a team at DeepSense has been getting data onto our system. So the one thing about your data was, I guess one thing we didn't really talk about was the data used, because some of the projects we're involved with are very heavy, many files, images, and things like that. So when you're dealing with thousands and thousands of images, having to move them onto our system, it can be slow. But can you tell us a little about the data structure that you had and the amount of data you had?
Um, I had quite a lot of data from the ECC GUI. If I remember correctly, I think there were about, not so much when you think about it now, there were about 157,000 rows. But then for the AZMP GUI, that was sent in text files to me for different months, for different years. So I had to go about, sorry, for different days in different months for different years. So I had to go about merging all of that into one data set myself. And also I had to use the SiteGreen utility for some other data. Well, I had to learn a wide range of technologies because I was using a Windows system. So I had to install a Linux utility for Windows command line in order to be able to download data from some systems. And I also had to merge some of the data myself. And when you code, sometimes you don't undo for some exceptions. And if there's different dimension data you add in, everything could just break. Because I encountered that a couple of times when I was trying to match the AZMP data sets, because it just came in different months from, I think, 2005 till now. So it was daily data that was dumped. So you had to take all of that and convert it into one huge data set. So that was part of the data engineering work that I had to do while I was working on this data. But I wouldn't say any one of them was overly large, to be honest. The major thing was, finding intersections between different data sets, because you're trying to predict one data from a couple of other data sets that you merged yourself and created. And you find that there's no intersectionality between some of them. So you have to artificially manufacture that. Like, I think the SMA came in every 20 minutes, the ECC came in every 30 minutes. Then some of the land stations came in every 1 hour. So you have to average the data sets going back and going back and going back to maybe every 20 minutes. So you can then find indexes which you can use to intersect those data sets and create a new one where you have your predictor values and the values to be predicted from the SMA GUI. So some of that data engineering work, that's where I did most of the work, because the major problem for me was the data was just different, not that it was so much. And some of the ways in which I got some of them, like the daily ones, then also the Coves satellites, weather station, that also came in, I think, every 20 minutes. It was data dump. So you had to measure all of that too. And in the end, I didn't get to use that, because in the end it was dimmed after we went through the entire thing. After I merged them, it wasn't good enough. So some of that work was just done to merge, as I said, but we didn't get to use them eventually because you found that there was not much information in some of them.
Which is crazy. So one of the things that I think that's probably, you've become a lifer and believer in managing data and probably good data governance. Was there any lessons learned that you had or any rules that you'd share about how best to manage data?
Yeah, for me, I prefer, what I learned is you should always have a data model that you'd want to use, what you think is important for you to keep, or better still, just have a data lake, keep all your data in there. And when you need to, you can pull things out. Because having to go through different sources that have different data formats, have different fields that they track, or they could be the same fields but with different names. I wouldn't know if they represent the same values until I spoke to either Toby or Toby spoke to somebody in the Department of Fisheries, and just that communication hoop, just going around just to get simple information like, oh, this column is the same as this. It's just a different name, or maybe sometimes the buoy is average, maybe the buoy added plus something to it. So you'd have to just get rid of that too. All of that, that was where I figured, I think I put in that recommendation that Cove should have a data lake somewhere where they collect their data, or partner with one of the organizations that they already partner with to create a proper data model, data dictionary with definitions and whatnot, and have resources that could help explain that data. Because all I had was Toby, and sometimes he didn't understand some of the data they collected, and in order to get the person, it could take 3, 4, 5 days. And sometimes I know they're busy also. You'd ask for, qualified data and you just send you a text file that you can't convert because the extension is wrong or something.
It's a great point because almost every organization probably goes through this, right? Whether you're an organization that's pulling third-party data or internally, you have corporate history that gets lost. So over time, somebody might remember why you called something sales underscore total. And then later on, people are like, wait, is that our total sales or is it minus something? Like there's having this structure around information is really critical because then you end up spending so much time cleaning and processing that data, which makes sense. You did that classic 80% of your time is preparing to train for those models and 20% actually gets to go towards training them. So in terms of some of the things that you can think about your experience with the DeepSense project, what recommendations would you give to students who are looking to do machine learning projects? Is there anything that don't be afraid of or any considerations that you would share if you wish you'd known?
Yeah, firstly, I'd say be confident because I'll be honest, in some of those meetings, my legs were shaking. Like I was like, get a hold of yourself. Come on, when you present, get a hold of yourself. So firstly, I would say be confident. And another thing is you should communicate faster. Like if you don't think something is possible, like when I was talking about, the stakeholders wanting me to do things and I was just trying them out, even though sometimes, when you do the cost benefit analysis, it just wasn't the right approach to take. Sometimes you should, be able to put it where the box stops and say, you don't think this is possible, just be honest with them and explain that, no, this is a better approach. Because we find that they're more welcoming than you expect or thought. And also, I would also advise to take a modular approach to the machine learning problems. Like determine the first problems you're trying to solve. Is it a classification one or, try to engineer this particular data set this way to maybe convert values within a certain range to, ordinal values or any things of that sort. Because for me, when I started, like I mentioned earlier, I tried to do everything all at the same time. And it was creating problems for me because you realize that, okay, there was a snag somewhere. In fact, the first thing I did, the mistake I made, I put all my code into one Jupyter file. That's the very first thing I did. And you find out you have to be, jumping through cells, going back to rerun something when you change something. So just try to take a modular approach and also, take advantage of every resource that's provided for you, like Chris for one. Because in the beginning, I just thought, oh, let's impress them, try to do everything yourself. But, with Chris was the one that came up with the idea of averaging the data sets so that you can find intersections between them. And Chris was a great help for me. So firstly, take advantage of the resources you have, whether human or material in any form. And also try to take a modular approach to solving your problems. Don't just write everything all at once. Figure out what you need to do maybe for a week. Like, agile, what is just an agile or sprints. Figure out what you want to do for a week. Go for that. Then go for the next one. Don't just try to do everything all at once. And also, like I said, be confident. Everybody has this imposter syndrome. I still have it till now, to be honest. If I want to apply for something, I still get, I'm not sure, I should over prepare all of that. But be confident, just try it out, talk to them. You find out that, because I was shocked. Okay, here's something I found out. I thought, Chris should know everything and all of that. But then when I was doing the regression problems with neural networks, Chris was like, he's never done that before. He hasn't seen where it was done. So I had to do the research myself. Or when I had to save some of my models, instead of using the H5 file, I used Pickle because you can store in Python and Python. He didn't know that. So the fact that I knew that and he didn't know that, I was like, yes, you know something at least. So, just try to be confident.
That's all great advice. I think, when you talk about all this stuff, every time you walked into a room and we had conversations with the stakeholders, I was like, oh my goodness, he's amazing. He's so smart. He knows everything. This is fantastic. So it is, you came across as you knew everything and were capable and asked questions. So it's incredible what goes on behind the scenes in someone's head versus what you see out in reality. But I think this is all really great advice for students. And, we're hopefully going to share a lot of what you're saying because they're all going to be in the same situation, whether they're working on a project with DeepSense, whether it's something they work on during a master's or a thesis or an undergrad or a PhD, or when they move out into the career of their choosing and they're dealing with people. So all great recommendations. Now, one of the things I'm curious about, you talked about the struggles of getting over the hump of and hurdle of going and using some clusters. Do you think in the future, I don't know what currently, and you don't have to get into things that you currently work on, but whether you're doing it now or in the future, would you use your laptop, or would you more easily migrate to try to use something a little bit different that's not your laptop?
Um, I'll be honest. I think I'll try to use my laptop first for the simpler things because it's just easier and it's convenient, and you just have it on your desk here. And, I mean, it's just straightforward. But and to be honest, there are not so many, other open source or available clusters apart from maybe Heroku, Simply Compute, or AWS. And the free tiers aren't the best. They can't handle some of the projects you have to do by yourself. So, and your computer can't too, to be honest. But for simpler projects, I'll go with my computer first. And for other things, maybe you find free clusters or free public clouds somewhere that you use. But the thing about free public clouds is that they have limits. So, I mean, it's free. It has limits.
Sorry. Yeah, absolutely. That's yes. There's often many services available to you publicly. It's just what you're getting into. One thing that is great is a lot of organizations offer, especially companies that are startups, they offer them a bunch of credits and cloud credits for them to go try new things. But it's not always the GPUs that are the giveaways that we currently offer. So in terms of some of our things that we're going to talk about today, I have a couple more questions that I want to come back to, but we do, please feel free to submit questions in Q&A, but there is one question in here that says, do you prefer the laptop or cloud-based notebooks like Colabs and Azure notebooks?
I haven't used Azure notebooks before, but I've definitely used Google Colab. So I prefer, to be honest, for me, I think it depends on the situation. If it was something fast, I might just use Google Colab. But if I want to keep some control over my, my compute system and how I use it, I'd prefer to use a cloud. Sorry, I prefer to use my laptop or a private cloud or something of the sort. But I definitely use Google Colab for some of the projects that I do also. But I have never used Azure notebook, so.
Perfect. One of the other questions someone asked, and I have an answer, and then I'm curious about your answer too. So why do organizations hesitate to incorporate AI and machine learning predictions into their business model? And I think there's a couple of different reasons, but in what I've seen, I think one of the things is they don't know what they can do with it. So I think there's a use case identification where if you don't have someone with that expertise and skill, you're probably focused on generating revenue and doing other things. You're not thinking incremental. There's a lot to go and build out an AI solution, especially if you're going to use it real time. And if you don't have the existing technology stack, you don't have the resources to do it, your data's not coming in. I mean, your conversation now talking about trying to pull data from multiple sources, building that in real time would be a real hurdle. And so I can see why organizations are a little reluctant. I think another thing too, though, is you might have a solution you want, you don't necessarily have the data that's appropriate. And I think organizations sometimes forget that you can go and train a model, but unless the incoming future data you're going to use that model for predictions is the same, this model needs to be retrained again. And I think that's one of the biggest things. We talked about you're building a machine learning model to make a prediction on a buoy for wind speed and wave height. And if all of a sudden conditions drastically change in our environment with climate change, at one point that model is going to have to be retrained. And so I think sometimes it's a return on investment too for companies and knowing when is a good time to make that investment. But do you have any other suggestions or reasons why you think that some organizations might not add those predictions into their business models?
For me, I currently work in Deloitte. So I don't know about for the business model, but I do know about clients. For clients, they also have this fear of the ethics of, say, machine learning or deep learning. You go about, you build your model, and then how sure are you that that model always gives the right prediction at the right time? There's that problem. People don't want to get sued over things like that. Where you're telling them to have absolute confidence in this, and then maybe somewhere along your training or your evaluation metrics, you made a mistake and it's not right. So, but I don't know. There's a catch to it in being overly confident in what your predictions are, or say how you built the model is perfect or something like that. And I know there's a marketing side of things and people say wonderful things about them, but it's a constant worry because in my company they always emphasize the ethics of machine learning, and we try to democratize it by making it go through different experts, especially for the evaluation process for some of those models. So I feel like if it's going to be a part of your business model, a money maker, the ethics, like I mentioned, are you saying that your clients or your customers should have absolute confidence in this? I think that matters a bit too. And like you also mentioned, the technical cost. Because for me, I believe I'm still a baby in machine learning. And you see some of the things that, some of the requirements, even like to get a job, you don't find so many people that are as qualified to go out and, especially for a startup, build up that stack, build a data product from scratch. And also we're trying to get this idea that, machine learning is just, say, coding, but there's a big difference, especially for neural networks. It's more mathematics and linear algebra and things like that. And most people, I don't know, but like most people I know and from my workplace, we focus more on the utility of it, the usage of it, not building out or to evaluate the mathematical side of things when it comes to it, because I'm just a computer science graduate to begin with, and what I know how to do mostly is code and all of that, not the mathematical side of things, the core maths concepts.
It's a great one.
I think the major thing, yeah.
Sorry, you go.
I was going to say, one of the other major things for me is the ethics of, using the machine learning to build our products for customers or clients.
Absolutely. And I think I was listening to a really good podcast the other day that talked about, as you go down that flow, you essentially need to know what the problem is. You need to have the data. You need to have context of the data, which is exactly what we went through with understanding the buoy data, for example, the context. And then you get to the algorithm. And the algorithm is the last thing. And it may be an actual neural network, or it might be something that's not as complex, right? And the ethical challenge, you learn about all these different situations where, models have been trained to diagnose and predict cancer, but it ended up the data sets weren't accurate. Or, look at anything related to facial recognition and the vast array of implications. And it goes, bias doesn't necessarily have to be something that comes across as is related to public facing either. When we talk about bias in the data, if you go and extract all of the winter data because it was volatile off that buoy's not going to work in the winter anymore because it's biased to non-winter season. So there's many different challenges. Okay, we have a couple other questions.
Because I also remember Toby too. So I just want to say, Toby now he's a director in the Department of Fisheries, but he was my sort of liaison when I was with Cove. I remember him and Captain Ray asking me, "Are you telling me that when you're done building this model, I can look at, a prediction from it and say, okay, yes, I can go surfing today?" And I was like, no, that's not what I'm saying. This is experimental in nature. So things like that, just exuding absolute confidence in your predictions. You can't be so sure about that, to be honest.
It's like autonomous vessels, right? Or autonomous vehicles. How much faith do you put in something that as it's getting trained? But it's good as a guide and an alternative and a redundancy measure, but maybe it's not the only solution. One of the questions we have is, I'm getting involved in machine learning in Python, but I'm not interested in learning R at all. That's an interesting one. Can I move ahead with just Python and learn deep learning and other concepts? How important is R, Scala, Julia as a data analyst? Julia is getting more and more popular, but to be fair, I'm interested in hearing what you think from on the outside, like in the world of consultancies and things like that. But R tends to be more academic in nature, and I'd say Python's not. Do you agree?
Yeah. Python is more general purpose. Like you could do machine learning in MATLAB, but you don't see companies that data products use a lot of MATLAB, to be honest. So I feel like Python is easier to learn than its general purpose. But I wouldn't say that you should be averse to learn something new or learning R. I haven't learned R, but I intend to eventually. So I would say, always try to have, for me, like in anything you do, always try to have two alternatives. If you were going to data science and machine learning, you could do Python R or Python Julia. I'm not so sure about Scala. Where I mostly saw Scala was in Spark, like Apache Spark and things of that nature. But Julia is coming up, but Python is still the number one for now. Even R, they don't use R as much as they use Python. The only issue with Python is it's a bit slow. That's what the problem is. But then Python has good integrations with C, Python. So most of the heavy lifting is done with C under the hood. So I would say Python is, you get good jobs, you get everything if you do Python for machine learning. So that's good.
I think one thing that I've said to some students before too, when we talk about what languages they should focus on, I think there's a couple of pieces. One is if you know one language and you know it well and you've learned concepts, it shows that you have transferable skills. So maybe eventually you're going to pick up R and that's great. One other thing to think about though is if somebody is posting jobs and you're applying to them, if you have HR who's looking for something and you mentioned Python, but the job description said programming languages such as R, you have to be really careful that someone doesn't all of a sudden go, oh, they don't know programming languages because they don't know what Python is. So that's the only time that I'm cautious about saying, I really only do Python. You want to make sure that you're not excluding yourself from something for someone just doesn't understand the language of what programming languages are available and how they're comparable, relatively comparable. And I think, to be fair, you find, I've heard of different organizations where they have people who work in both languages. There's different platforms and different things that will allow both. And yeah, it's whatever you're most comfortable in, because all of this is not easy. So may as well do something that you're already comfortable in and keep going with it. Okay, so we have another question. What's the strategy for validating predictions against real world events? Well, do you want to talk about your model and specifically about what you were doing for validating that?
To be honest, we just, we already had, it was a supervised training model. So for us, we already had the right values for them. So we just compared our predictions against them. You checked the residuals, maybe the difference between your predictions, the main difference between your predictions, because you can't get every one. You have to get an average of them, of the difference. So, maybe your model is within this interval on average, every time is within this interval of the actual value. So you could say, it's relatively good compared to that. I don't know about, if there were no metrics to test your accuracy against. I don't know how I would have done with that. But for us, we already had some of that. We had the correct data and we just compared our predictions against them.
And I think, to be fair, once, once you split that training, test, validation set of data and you feel your model's pretty good, and if you launched it live, it's continuing to monitor it as well, right? Sometimes organizations do A/B testing against two models. Sometimes they don't use a model with certain segments. So if you were using it with customer churn, for example, maybe you only use the model with half of your population for a while to make sure that model's performing. I think it really depends on the situation. But in this situation, I think for us, what would have been great is if we're still working on the next step of taking your model and moving it forward and further refining it and trying to make it real. The thing that will be really valuable is using it real time and having a live prediction and then comparing with what the buoy itself is actually saying. And that hopefully will be where we end up. There's one question here that I'm fascinated by because I've been doing a lot of reading on this lately. Would AutoML eventually replace data scientists one day? And one thing I think is fascinating is maybe long after we're gone, but if you run into the examples of what you ran into with your data, AutoML wouldn't know how to handle negative wind values. It wouldn't know that that was a problem. So AutoML would be great if you have data, you have first a lot of computational power, you have clean data, and you can push it in there and let it figure out what's the best model. But I don't like knowing what you've went through for you to try to build this model. What do you think? Is AutoML something that could have replaced what you did?
I don't think so, to be honest. Maybe someday, because we all code, right? So we know that it's mostly from the premise you have in your head when you write your program. Because even if you were to, use AutoML, what would be the purpose? Say I have a specific business case for myself and the data needs to be engineered for that. You still need people to, fine tune the data sometimes because they're the ones that can sift out, in relation to the business case, they're the ones that can sift out, what metrics would best, what metrics would best represent the solutions for your business case and things like that. But I feel like the purpose matters a lot because you can't just say we're trying to predict wind and wave height for a particular reason. How do you capture that if you don't have, people to sift through the data and engineer it for that particular purpose? But if you're talking about generally, possibly you could do that someday.
It's interesting. It's interesting. You could. I think then you get into the ethical challenge, right? Do you want a solution figuring out if you gave it a pile of data? Like maybe the goal is that you can have a bunch of people who don't know anything about machine learning and don't have the resources and technology. They can take their data, throw it into something and let AutoML come up with the solution. I think then the risk though is now you're worried about bias in general. And that's why, some companies would have third-party people like a Deloitte go through and validate and make sure their models are ethical and honest and fair.
I also feel like, AutoML is on the far end of the spectrum, like towards the end of your data product. From the beginning stages, you still need, I don't know if you call them data sciences, but you need a guide, to be honest, from the beginning stages, because you're in the final stages when you're thinking about AutoML and things like that. Some of the thought processes that inform you going about building out a solution for a particular business case, that needs to be done prior, and they need people to understand the business case, what's possible with models, things of that nature. Because from my experience, in school, we're just all up with our finger happy, we just go about and build out the models and things like that. But for me, when I was in this project, every step of the way, there had to be like a reason, what's the best way, why you needed to do it, things like that, who understood what, things of that nature. So you could be hearing all the buzzwords about ML, but obviously there are people also behind the scenes that have to manage all that process that feeds into the AutoML in the end, into the AutoML framework.
Absolutely. So does anyone have any other questions? I'm just double checking to make sure that please feel free to throw them out there. But one last piece is, I'm curious, and I have to ask because I ask everyone this, and so DeepSense, we're focused on growing the ocean economy through artificial intelligence and machine learning. Tell me about what you knew about the ocean economy and what you've learned since then.
To be honest, I didn't know much about the ocean economy going in. I was just looking for an internship, I'll be honest. I just wanted a job fast. So that's when I joined. But, when I joined DeepSense, I saw all the research that was going on in the ocean economy. I realized how it contributes to the discussion, and even outside of that, to the rest of the world, such as fisheries, such as, helping maintain ocean balance for pH levels and things like that. And some of the other things the ocean does for us, like for what's it called, climate change, reflecting solar radiation, things of that nature, and absorbing heat and things like that. I wasn't exposed to any of that until I go into DeepSense. And in fact, if you told me machine learning and the ocean, I was like, what do those two have in common? But going into DeepSense, I was exposed to, other possibilities for the applications for ML. Even because I was in a startup environment, I was seeing some of the innovative things that companies were doing, like cracking robotics and things of that nature, and being able to talk to them. And, and I don't know, for me, I've always had this desire to be an entrepreneur eventually. And just being in that environment, seeing what people are doing, like open ocean farming, things I never thought about. I'm from Nigeria. What you see mostly are fish ponds, things like that, on land, not out there in the ocean. It just expands your world of possibilities for you, for the person. That's some of the benefits I had working with DeepSense. It wasn't like a regular, how do I put it, regular internship where you'd have to report to somebody every day. You could get, mundane. It was an interesting topic, an interesting project for me. It exposed me to some of the resources that are out there if you want to be an entrepreneur, like, because COVID, this connector events that we have, you see venture capitalists, people that could help set you up if you want to start up your business. You see opportunities to solve problems in the ocean space, and how a province can rely on the ocean so much. So the importance of the ocean in a province, something you've always discounted for, but you begin to realize that, okay, there are positives here too, and things of that nature. And one of the major highlights for me was also the fact that I felt like I had, creative freedom over the project for me in the ocean. Everything just made the ocean more intriguing for me because my entire experience was centered around the ocean. And I took so many positives out of my experience with DeepSense and realizing the benefits for the ocean, or, the importance of trade or things like that. I mean, you just see ships coming to the harbor, you never cared if there were currents 16 feet under the surface that mattered, things of that nature. So it was just something new and a refreshing experience.
Fantastic. Well, I want to thank you very much for sharing your story. And I think one of the most exciting things is the paper that you recently had published with Chris, who you've mentioned, and Jason, who's also on our team, which is very exciting. I think there was one thing that was the reminder that once you write a paper after you've walked away from a project, you end up coming back to our cluster to rerun some things and update some. So I feel like it's the project that never ends, but the beauty is you have a published paper out of it, which is always really exciting.
It feels good to be published, to be honest, because my master's didn't give me that opportunity. So it feels really good.
That's fantastic. I mean, I'm really happy.
I can put it up on LinkedIn and people are like, oh, he's smart. I'm not too sure about that, but yeah, it's good to be published.
Oh, I have one more question for you. I'm in Cape Breton University, okay? And so talking about working, there's other students like at Dalhousie, all the same job market applying for jobs. I'm trying to learn the best that I can through things online like edX and Coursera, all very great resources. And involved in some projects. I'm finding it hard to secure an internship in my field. Do you have any suggestions? So, I mean, one fortunate thing that we had was I ran into you. I'm trying to remember how exactly the first time that we ended up meeting, but we interviewed you, and then we interviewed some other students from other academic institutions as well. And we are fortunate that you had the skills that were required and the passion and energy to explore a project. Do you know, because you're a Max student, so you also had to, you were looking for that internship piece. What other methods were you looking for finding internships?
To be honest, I just went to, firstly, I went to job fairs. Then there was no COVID, so you go there and meet them, and I asked pointed questions like, what would you be looking for in a candidate and things of that nature. And what came back to me mostly was, yes, we know people are good technically and all of that, but we also want things like leaders, your extracurriculars, things of that nature. And also always trying to connect. For me, when I write my cover letter mostly, because I can't do that in my resume, I always try to connect I try to make things bigger than me. So I try to connect to the company's mission or statement or goal and, draw a bigger picture from it and how it can affect everybody else, or even myself. And, I sorry for lack of a better word, but I tend to kiss ass. I say things like, I believe that the particular company's edge is in its people. I like its people. I want to be part of its people, things of that nature. But before you do any of that, to be honest, I feel like you have to, develop yourself personally. For me, I think you just have to accept that you have to constantly develop yourself. And I know it's tiring because I feel it too. Learning is one of the most difficult things in life because I get tired of learning every now and then. But I subscribe to Udemy and I always take courses on Udemy, paid courses. And I try to develop myself every time. But also before I apply for a job, one thing I realized, especially if, say, you're in computer science, straight for new grads, it's not just about being able to code. It's also about, understanding tools that promote teamwork or social coding like GitHub, CI/CD, things of that nature, being able to use either one of them. But I feel like for an intern, the most important thing is you should be willing to learn. Just be open to it. Make it pointed. State it out there that you've seen this interest, you're interested in this. You tried other things before personal projects, and you want to see how you can add this to your portfolio, what you can bring into it, things of that nature, and always try to, how do I put it, be multifaceted in some type of way. Try to bring in other aspects of yourself from maybe other projects or other parts of your life into your job. Always just, even when you're applying, when you're talking to, and I find that being honest, it helps me a lot. I don't just go and say, oh, I can do all of this. I tell you, I can't do this. I haven't tried this before, but I'm willing to do this because, if you want to employ an intern in new grad, you're looking for them to learn. You don't expect them to know everything. So just being honest and be real. Try not to make it be like this, just a dialogue. Don't try to have an interview proper. And like I said, also, I try to connect. I have a bigger goal for the company than it sees for itself. Sort of like make their mission bigger, see how you can take it in different dimensions, and also do a little of ass kissing too.
I think I want to take that and share that with every student that I've met. I think that everything you just said is critical because it's not necessarily the skills that you have. You touched on like you've learned about the company. One thing that I think has been one of my biggest challenges in life, no matter what job I've held, and when I'm hiring people, whether it was for an intern or a full stack developer or a project manager, or a research analyst, you're looking for someone who has taken time to understand the website, answered questions about why they're applicable and they align with the corporate culture, why that they know something about the company, like actually put the name of the company and the title of the job in a cover letter, and it's not a copy paste from everything you've ever done. I think one of the things too, like in terms of there was comments about, what skills do you need? Well, I think one of the biggest things is go look at the future jobs you want to apply for, see what kind of skills they're expecting and start training up on those skills. So just because you have a syllabus that tells you here's the things you're learning. It doesn't mean that that's all you need to learn. And it doesn't mean that one program is better than another because you learn different things in a program. I think one of the things you need to know is how to go and seek out information on your own. Part of your career development and self-development is going and finding out new programming languages, new concepts, and kind of training up. So if you're really struggling trying to find those internships, part of it is stepping back and looking at how you're applying for those internships too. And then all of the stuff that Bill just said, that was perfect. Just one sec, there's one more question. I have to pop this thing up. LinkedIn, social media. Oh, and then other things like reaching out. So LinkedIn, social media, totally get it. Okay, and then last question, we'll end it. So this is, what algorithms are currently in the market do you think are effective and implemented at Loblaws and Walmart, real-time pattern association minding? So one thing that I'm gonna flag here that, we kind of talked about, and you touched on when you're talking about the ethical elements of a project, I think the algorithm's the last part. So, for your example, you chose 3 different algorithms for the same problem, and we're trying them to see how much they varied. And each of them was a little bit different depending on, and its performance depended on what you were trying to determine as a successful outcome, right? So I think thinking about what's the most important or interesting algorithm right now might be the very end of the spectrum. It's more, what problem are you trying to solve, and at what point do you think that this is a successful, reasonable measure? Would you agree?
Yeah, I agree with that. And I agree with that completely. Also, the algorithms have different natures. Some are best suited to different types of things. Like if you don't have so much data, you can go on and use things like, what's called ResNet or things of that nature. And also, there's also the fact that if you're just speaking specifically about algorithms and, they being implemented in specific organizations, it's really, most of them use deep learning, and it's really hard to get all your hyperparameters and your metrics right for a deep learning algorithm. So most people now use transfer learning, especially for different, if you're doing image recognition and things like that. They have model zoos from which you can download specific models. And so you have the basic architecture in place already. You just need to tune some hyperparameters. You need to tune more hyperparameters. So most of that work is already done. You just download a particular model from a model zoo online. It's called transfer learning. And all you need to do is just, change some hyperparameters. I don't know what they use in Walmart or any of that, but I know that there's this, trend and craze for deep learning and all of that. So I'm betting most of them will use that. But I also find that the simple algorithms are also very efficient, especially the bagging or boosting algorithms, the ensemble ones.
Right. So I think one thing that is definitely clear is people have expertise and domain expertise. And you did touch on the fact that you don't know everything, and that's expected. And I think one thing I find most fascinating, especially because I work with a lot of different faculty members in academic institutions who've written paper upon paper in certain topics. And then you ask them a question, they're like, but I'm not really an expert in that. But you are, you're the expert. And so no matter who it is, no one actually thinks they're the expert, and that's truthful. Like, if you have somebody who's an expert in natural language processing, they're not going to be the expert in computer vision. And so if you're looking to get trained up in a concept or an algorithm, you have to be careful, because you're not going to be, you can be one expert in one thing, but then the next job you want to apply for, they're looking for somebody who has a lot of skill than the other. So you're never going to win everything. It all is those tangible, transferable skills and knowledge set too. I think that's really kind of critical. Okay, so this has been a great talk. There's loads of questions that we can kind of cover off around what types of frameworks are really important and really critical. I think what we have is the makings of our next talk. So we have some questions that have come in specifically talking about different algorithms, its uses, different frameworks, and I think this is really great. But I won't bore you with answering some questions around various frameworks. That's another one we can save for another day. But thank you so much for taking the time to connect with us. This has been fantastic. And thank you everyone who's joined us. I hope you join us on some of our next talks. One of our next talks, we're going to be talking about communicating via email or other ways. And one of the examples that we're going to use is something like what Will referenced, which was trying to figure out the data that you have. So data might have been provided by someone else. How do you ask for clarity? And so how do you clearly communicate to someone who isn't accountable and responsible to you who might know something, and how do you try to get that information out of them in a clear, succinct way, in a timely fashion? And so we're trying to link it back to data, but it's around communication around data. So hopefully for those who are interested, you'll join us for that as well. But thanks so much for your time, and it's always great to see you.
Well, it's a pleasure to be on here, and I'm happy that I had the amount of attendees that I had, and it's just a pleasure. I'm lucky to be part of DeepSense and everything it's provided me going forward, because the project has been a stepping stone for some of the job offers I've gotten when I was done with school. So anytime, anything, I'd always be ready for DeepSense.
Thank you. I hope you have a great day.
Yeah.